Hello everyone. Now let us understand and run a simple ARM7 assembly program that counts the total number of spaces in any given null terminated string. The example string that we are considering is ARM7 counts spaces in this string. So here you can see there are total 1, 2, 3, 4 and 5 spaces. That is the final result that we need to obtain through this code. First, let's check if this code has any errors. No errors, so we'll go ahead with debugging. The very first thing we notice here is the assembler directive area, which defines a section of memory to store this information. Spaces here is the name I have given to that section of memory. Code indicates this section of memory contains actual ARM instructions. Read only because we don't want any modification to be happening to this particular code during runtime. Entry indicates where exactly execution starts. Execution starts at the very first label that appears after the assembler directive entry. Start, loop, done string are nothing but labels. Labels represent specific memory locations. DCB here stands for define constant byte. That is because each character of this string occupies 8 bits or one location in the memory. We use align here, which is again an assembler directive. Align prevents memory access issues by ensuring data starts at the correct memory boundary. This DCB here causes memory alignment issue. To solve that problem, we use the assembler directive align here. End indicates the end of source file. Now let's understand what's happening here. This is nothing but a pseudo instruction which copies the address associated with the label string into the register R0. As you can see, 24, that is hexadecimal value 24, is the address associated with this particular label. Now let me open my memory window to see what exactly is stored in that location. You can see some random numbers here, but if I right click and click on ASCII, I can see the exact statement that we considered here. So now I'll just change it back to its original format. I have obtained the address associated with that string. That is now 24. The very next thing I want to do is I want to initialize my counter, which is used to store the final result, with the value 0. Followed by that, LDRB instruction, that is load register byte instruction, is used to load a byte of data from the location pointed by register R0 and then place it into register R2. We use this because each character of this particular string requires 8 bits or one location. That's why we are using LDRB, and then we are incrementing R0 by 1 because once this data is loaded, in the next loop we need to point at the next data. So now let us perform the task. Yes, the value 41 is now loaded into register R2. Next, I am checking if we have already reached the end of the string. That is possible only if the character stored is the value 0. But currently that is not the case. So this comparison internally performs subtraction and updates the CPSR. But as you can see here, Z flag is 0, which means R2 is not 0, because of which this branch will not occur. That instruction gets ignored. So now we are comparing if the data we have extracted, that is the hexadecimal value 41, is it a space character? If that is the case, this comparison will set Z as 1. Let's see if that happens. No. Since it is not the case, this add equal will be ignored and branch operation will be carried out. Okay, so this particular task of checking if we already reached the end of the string or if a space character is encountered goes on until we finally reach the end of the string. So now let's continue this. As you can see, the next character that will get extracted is a value 20, which is associated with the space character, because of which the first comparison is anyway false, but this comparison between R2 and space character generates a value 0 and sets Z as 1. As soon as Z is 1, it means EQ condition, that is equal condition, is true, because of which this addition will happen. Okay, so as you can expect, every time there is a space character like here or here, this R1 gets incremented. Let's see that happening. As you can see here, almost all characters are already loaded and checked. Now the very last character, that is null character, is loaded and compared. So we already know that current value stored in R2 is 0, because of which Z is set as 1 and the branch will happen to this infinite loop. Okay, now if I check the content of register R1, we have the final result 5 stored in it, which is exactly equal to the total number of spaces present in this particular string. That's all about this code.